Hey guys, welcome to another video. Today we are looking at storing user passwords. We're going to see the best practices of how to store passwords in your database. Now, to answer the obvious question, what is a password? Basically, a password is a secret string of characters used to authenticate a user's identity and allow him to access the system. Put simply, it's just a random set of characters that you type into a form which allows you access to a website or a web app. A password is weak or strong based on how easy it is to guess it. We all know that there are weak and strong passwords. Now, what makes a strong password is the combination of characters that you use it. If you look at the example, this is a weak password because it's fairly easy to guess it, right? Anybody could guess 1, 2, 3, 4, 5, 6. But the second password is really hard to guess. Now, a good practice is to have a mix of characters and numbers in different cases. So, usually you will have passwords which have both upper and lower cases, and you will have numbers, special characters, etc. The more characters you add, the more styles of characters you add, the more secure and strong it becomes. Now, when it comes to storing data, this is how we store data in a database, right? We need a data model. A data model is nothing but how a data will be stored in a database. That is the structure of data in a database. So if you are coming from a developer background, you know that a user is the basic entity in any database, any software. Now, a user, even though it has a lot of properties, we are just considering the three most commonly used properties, which is one, it will have an ID which uniquely identifies a user in the database. We'll have an email, which is usually the email address, and then we will have a password. So this is how a basic system will structure the user model. If you take an example where we have values for the user data model, this is something that it will look like. Now we have the ID column which has values 1 and 2. Usually it will be more sophisticated than this, it won't be plain numbers. Then we have the email column, we have the password and other properties. Now what is the problem with this? Imagine the database is compromised. That means someone gets access to this database. All the passwords of all the users are now with that person, and he can easily log into anyone's account and access it. So what do we do? Now there are two main ways we can protect this from happening or prevent this from happening. The first method is called encryption. Now what is encryption? Encryption is the process of converting text into an unreadable format using a secret key. So basically, you take your password, you convert it into an unreadable format. Now when we say unreadable format, we think that it's something which humans cannot read, but it's not like that. It's just changing the string into another string using a key, but the output string will actually make no sense. Now this output or the converted string is what we call a ciphertext. Now here's an example. Say your password is hello, which is really weird, but let's suppose. Now say the key is to shift each letter in your password by 3 letters. Okay, so if you look at the example over here, now H is becoming K because it's shifted 3 times, E is becoming H, L is becoming O, and then O has become R. So in the end, your input password has now become Kur. Okay, now that is the ciphertext. So your input password has become into something which makes no sense. That is why we say it's in unreadable format. And to do this, we used a key, and the key is to shift them 3 positions upwards. This is called the Caesar cipher, which is a very popular encryption algorithm which is taught in schools to children. Okay, this is like one of the first forms of encryption ever discovered. Now let's say that we use the encryption, the same key that is shifting three letters on our existing passwords. So now the earlier passwords have changed to the current password. So this is actually what we have seen in the earlier slide. So earlier it was, if you go back, you can see the earlier password was Sunday and despicable me, which has now become something gibberish. Okay, great. Problems. What happens if the database is compromised? No worries, right? But even if someone gets this password, he cannot do anything with it because that's not the actual password. Okay, so he protected that. What happens if the key is compromised? Oops. Now, if the person gets the key, then all the passwords are again compromised, right? You can use the key to get back the actual password, right? Basically, he will just go three letters backwards and you'll get the actual password. Okay, then. Now, let's learn about the types of encryption. I know you're wondering what is the use of having such a password, but bear with me, we'll reach there soon. Now, symmetric. The same key is used to encrypt and decrypt the data. Now, if you see the previous slide, here we can get the old password by shifting the existing password, that means the ciphertext, back three letters. And to get the ciphertext, we can move the password three letters upwards. So the same key is used to encrypt and decrypt the password, right? Such a type of encryption is called symmetric. The key is called symmetric. Okay, now some of the popular algorithms which use this type of encryption is AES, sorry. It's advanced encryption standard. Now, where do you find this kind of a encryption is in your disk, on your hard disk, or maybe on Google Drive, or any other files in your system. Okay, they're actually protected using AES. So even if your disk is stolen, and if it is logged by using AES encryption, it's not, the data cannot be retrieved by the hacker. Okay, you have to provide the key to the hacker, then only you can actually access the data. The hacker can access the data. So this is one form of protection. Now there's another type of encryption called asymmetric, which means that different key is used to encrypt and different key is used to decrypt the data. So, unlike the previous case where we were using the same key to encrypt and decrypt, here we use different keys. Now, this might sound weird because how can this happen? Well, there is a popular algorithm called RSA, which is actually used in such cases. Okay. Now, you might have heard about public and private key encryption. Okay, you might have seen when you're generating, adding tokens to GitHub. I mean, like adding a device to GitHub, or you might not have seen it popularly being used in your daily life, but your browser, which communicates via SSL, it uses this kind of an algorithm for HTTPS. Okay, so any data which you send from your browser to the server and back is protected, is encrypted using the RSA algorithm. So, if it's all about the key, is it less secure? Now the question arises, right? Like, what is the use of encrypting data if the key can be lost and it can be, like the data can be accessed easily? Well, it's not less secure. Let's see why. You see, to get the password, you need to get the key, right? Because even if the database is compromised, the user or the hacker cannot do anything until unless he gets the key. So the main motive or the main game is to get the key. Once you get the key, you can get all the passwords. Now, here is how encryption works. The key is usually 128 to 256 bit long. And the key is not as simple as shift three letters up or shift three letters down. No, it is usually a very long string which is pretty hard to crack. Now, let's take an example. So, this is a 128 bit long key. This is used to encrypt a password. See, to get this key, there is no other way except guessing what the key is, okay? And that is what most of the hackers today use. It's called brute force. Brute force is nothing but guessing what the key could be. So, if you take this key, imagine you want to guess this key. What will you do? You will guess that in this position, because it's a binary digit, it can be 1 or 0. For this position, it can be 0 or 1. For this position, it can be 1 and 0, and so on. So, you get the idea, right? So, if it's 128 bits, then you'll actually need 2 raised to 128 possible combinations. Okay, that many keys are possible. That is actually 3.4 into 10 to the power 38. That's like a very huge number. Okay, so the hacker will have to make so many combinations to get the actual key, and then using that key he will have to get the password. So making a long key is the main motive, or is the trick to make encryption secure. Now, another way to secure passwords is by a method called hashing. Now, what is hashing? Hashing is the process of converting text into an unreadable format of a fixed size. But it's the same thing, right? It looks similar to encryption. What is the difference? Well, the fixed size thing is the difference. Now, this converted text is called hash code. Or in encryption, we were calling it ciphertext. Over here, we call it hash code. Now, so what is the benefit of hashing? You see, in encryption, it's a two-way thing, right? You encrypt a key, encrypt a password using a key, and using the same key, you can decrypt it back. But in hashing, it's mathematically impossible to convert it back to its original form. You see, unlike encryption, hashing is done via mathematical functions which do a lot of calculations and generate a unique hash. Okay, and it's not possible to convert it back to the original form. Now, how it does it is a broader topic which can be discussed in another video. But for now, you have to understand that it is mathematically impossible. Also, hashing is really fast. Unlike encryption, it generates a fixed size string. Alright, so no matter what is the input size, the output will always be a fixed size string. This actually helps make the process of this conversion really fast. Okay, and it's a mathematical function, so it's basically calculations which the processors actually can do very well. So it's really fast. That is one thing which overtakes encryption, and the second thing is that it's not possible to convert it back. Now let's take an example of hashing. We'll take our old password. So you see, we have Sunday and Despicable Me, right? Now these are the hash codes which are generated for this password. So if you see, the count of characters is 64, which is what I said, that it generates a fixed size string. This algorithm, or this hash code which is generated, was generated using an algorithm called SHA-256. Now this is a very popular algorithm used in the industry. So this is how the data looks after hashing has been applied. So the old password of Sunday123 has now become random characters, which makes absolutely no sense anymore. So problems. What happens if the database is compromised? No worries, right? Yeah, they can't get back the original password, because from hashing it's literally impossible. In encryption, there was still a possibility because we had a key. What happens if the key is compromised? Again, no worries, because there are no keys in hashing. So great. Now to the summary. So what did we learn today? Now we learned about how passwords are stored in the database. Great. We learned why it's a bad idea to store them as plain text, because if the database is compromised, you lose all user data and then they will come behind you. Encryption. Then we learned what is encryption, okay, how it works. It uses a key to convert the meaningful text into not so meaningful text. We learned about what are symmetric and asymmetric encryption. Um, we we saw how there are symmetric keys which allow to decrypt and get the original password back. We learned about asymmetric ones which don't allow, or we which need different keys to decrypt and encrypt. We learned how there's a dependency on the key, because if the key is lost, everything is lost. But we also saw that it's really hard to crack the key, and we learned where it can be used, or where it's used, the use cases of where encryption is used today, and we learned about the algorithms like AES and RSA. Then we learned about hashing, which is a mathematical function that allows to generate a unique hash for passwords. And we learned why it's more secure than encryption, as it doesn't allow to decrypt it back, I mean reverse it back to the original password. And we learned what algorithm is used in hashing. Great, that's all the time we have today. If you did like the video, please do leave your comments, good, bad, whatever you feel like, and do like and share it on. Thank you guys.